Hi everyone, just wanted to take a minute to talk a little bit about our next topic, trigonometry. So the trigonometry that we are specifically going to be focusing on for this class is going to be something called right triangle trigonometry, which, as you guessed, is in relation to right triangles. In Algebra 2 or in later courses, you will be studying kind of trigonometry in a slightly different sense, and it all lumps together and it all works together and interacts. But we're specifically going to be dealing with it in relation to triangles. All right, so what are our goals for today? Well, we're going to talk about the different trigonometric ratios based off of right triangles, and we're going to use those ratios to solve for sides and angles. So if I gave you a triangle that looks like this, you probably would look at it immediately and go, well, I think I could do something with that. And based on what we know right now, despite your best efforts, there's really not a whole lot you can actually do. I mean, you could tell me what this angle is up here, but that doesn't really give you this, right? I mean, we know if this is 12 and it's across from the 28, this is going to be bigger than 12. We don't know what it is, we just know it's bigger than 12. You can't use the Pythagorean theorem yet because we don't know the other side. So there's really not a whole lot you can do. It looks like you should be able to do something, and you can, you just don't know it yet. But that's actually what we're going to be focusing on today, of how do I deal with this situation. So the solution to that is you use something called trigonometry. So really the purpose of trigonometry in here is going to be with solving for different sides and angles and things like that. You're going to see a little bit more of where it comes from in Algebra 2 or a later course, where it will make a lot more sense when you kind of start referencing it with other pieces of information in regards to functions and graphing. But for our purposes, we're going to be looking at it in terms of triangles. So we are going to be looking at them in terms of ratios. Specifically, we are going to be looking at these three trigonometric ratios. We are going to be looking at sine, cosine, and tangent, which are things you may or may not have heard of before. Additionally, there will be an abbreviation called SOHCAHTOA. That is another thing you may or may not have heard of before. But let's go over what exactly it means. So if we are dealing with right triangles, as it turns out, their ratios end up forming a kind of a specific pattern. And depending on which ratios you were looking at, it makes sense to kind of think of it in terms of different functions, right? So one of the ratios that we will look at will be the ratio of the opposite side to the hypotenuse, all right? And you're probably wondering, well, how do I know which side is the opposite? So when we are looking at a triangle, we know it's a right triangle, there's two other angles that you have to choose from. You're going to pick one. It doesn't matter which one in general, but you're going to pick one. Okay, that's going to be your reference angle. So referencing that one angle, you have an opposite, which will be the side across from it. And then you'll have an adjacent side, which will be the side that kind of borders it. Now, that does depend on the location, as you can see in this picture, right? If I had this be my angle, now over here is my adjacent, and over here is my opposite, right? So it depends on the location of the angle. So that is one of the tricky parts of it. But you do kind of care about the opposite or adjacent. Now, obviously, hypotenuse is not going to change, so don't start changing hypotenuse on me, because it is always the longest side and across from the right angle. All right, so the first ratio that we are going to be looking at is opposite over hypotenuse, and we look at that in terms of something called sine. Okay, so what I wrote here is sine of theta. Theta is going to be the name for your reference angle. And it is always going to be equal to the ratio of the opposite side over the hypotenuse. So these are going to be lengths, right? So they're going to be something like 7 over 11 or whatever. Based on the fact that this is an opposite and a hypotenuse, right? And we are dealing with triangles, hypotenuse is going to be bigger. So this is going to be a fraction. But that does, because sine of theta is equal to a ratio here like this, right? You're putting it as a fraction. That just means sine of theta is a number. Don't forget that. It's going to be very important when we're solving these. So a way for you to remember that is when we're looking at the whole thing of SOHCAHTOA, you have SO, S-O-H, sine opposite hypotenuse. Now, moving on, you have cosine, which again, you still have to reference in terms of the angle. It is very important that you include the angle here, because there's two angles that you could be talking about, and I need to know which one you are talking about. In general, you just write theta. But if you have specific numbers, you would write a specific number. Now, cosine, obviously, we still have the hypotenuse. Adjacent over hypotenuse. Right? So again, it's a number. And then finally, you have, again, and you have the hypotenuse. This is what this is going to be, less than 1. And we have tangent, which is going to be opposite over adjacent. Now, tangent obviously is going to be the most variable in terms of what values you're going to get because, we don't have the obviously bigger number on the bottom. It is going to be opposite over adjacent. Now, that is how you can remember that. So, katoa, so sine opposite over hypotenuse, cosine is adjacent over hypotenuse, and toa is tangent opposite over adjacent. All right. Now, that was a lot of information, but let's just take a step back. Now, how do we write these? Just remember you need to have the reference angle. You need to. All right? And I know it's very tempting to read this as sin, but it's sine. So sine of opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. Again, it would be different if I had this be my angle over here. If this is my angle, this would become opposite. This would be adjacent. I, one more time, cannot stress this enough. Your angle, your opposite and adjacent can differ depending on the angle. And I'm only telling you this because it is very easy to forget that that can happen, right? So here's an example. So let's say we are dealing with a right triangle up here. We have two angles, A and B. Sine of A has X as your opposite and Z as your hypotenuse. But sine of B has Y as your opposite and Z as your hypotenuse, right? Notice how the opposite have changed, right? The hypotenuse has stayed the same. Similarly, with cosine of A, you have your adjacent now with Y, and your adjacent then becomes X when you're dealing with B. And then tangent of A and tangent of B, they are just flipped. Okay, they have nothing necessarily the same, except that they are just flipped. Okay, so it is very, very important. Now, these could be numbers as well. So if I had something like, 7, 8, whatever that would add up to, or, 3, 4, 5, right? You would have 3 over 5, 4 over 5, 4 over 5, 3 over 5. You see what I'm saying? That's what we're going to ultimately end up with. Now, one of the things that you might be thinking to yourself is, well, if I have, hypotenuses on the bottom, why can't I put them on top? Well, those do exist. We just don't really talk about them that much in terms of geometry, just because we don't really need to. We can get all the information that we need for the purposes of geometry with what we are doing, just from sine, cosine, and tangent. But there are reciprocals of each of these. The reciprocal of sine will be cosecant. The reciprocal of cosine is something called secant, and the reciprocal of tangent is something called cotangent. They are known as cofunctions. Well, some of them are cofunctions. Sine, cosine, cofunctions, secant, cosecant, cofunctions, so on and so forth. But as you can see here, they are just taking what you already know and flipping them. So it's really not anything additional that we need to worry about for the purpose of this class. They just do exist if you ask. All right, now, what do I actually do to solve these problems? I've talked a lot about what it is that they are, but I didn't really talk about how to solve them. So typically when you have to deal with trigonometry, you're given some sort of right triangle that is not a 45-45-90 triangle or a 30-60-90 triangle. I do want to stress that you can use 30-60-90 triangles and 45-45-90 triangles and use trigonometry the way that you would for any other triangle. It's just you do not need to use trigonometry for those triangles because you already know that they follow a specific pattern. All right, so essentially what you're going to be usually given is you're going to be given some sort of angle and then two sides. Okay, so because you're going to be given some sort of angle and two sides, you have to pick which trig ratio you're going to be dealing with. So let's take a look. We have our angle here. I'm going to call it theta. Theta is equal to 46 degrees. It's important that you know that it's degrees. We have the opposite of theta, being a number, and we have the hypotenuse is what we are looking for. So we are dealing with something involving opposite and hypotenuse. So going through our head of SOHCAHTOA, right, which one has O and H? Well, the first one, sine. So I know that sine of theta is equal to opposite over hypotenuse. Well, let's ask ourselves, what's theta? Well, it's 46. So sine of 46 degrees is equal to, what's my opposite? 91. What's my hypotenuse? Well, it's x. All right. Now you might be asking yourself, well, what do I do with this? Because I don't know how to solve this. Well, we know if this side is ultimately going to be a number, right? Because we know x is a number. It's just a length. We know 91 is a number, so this is a number. That means that sine of 46 is also a number. I don't know what it is, but it's a number. Okay? So just keep that in mind. It is a number, so you can kind of do the stuff that you would normally do with said number. Now, since I have to solve for x, I got to get x equals something. So let me multiply both sides by x. I would get x times sine of 46 degrees is equal to 91. Now, again, sine of 46 is a number, right? It's its own thing, right? So I'm going to divide both sides by that. And we got x is equal to 91 over sine of 46 degrees. Now, you're probably looking at that and going, well, I don't know what that is. That doesn't help me. All I know is that it's going to be bigger than 91. And I mean, yes, it will. It will be bigger than 91. But to show you how to do this, let me pull up the Google calculator. So if you just Google calculator, you'll get this. Now, our goal is to find what x is equal to. We know it's equal to 91 over the sine of 46 degrees. So you'll notice up here we have two buttons. You have rad and deg. You want degrees. So that stands for radians or degrees. We are dealing with degrees in geometry. In later courses, you tend to deal a lot more with radians. It's really just a matter of the context. If you are dealing with a graphing calculator, the way to change it and make sure you are in degree mode would be to go to mode, which is right next to the second button, and then scroll down until you see radian or degree, and then key over and hit enter on degree. Okay, so how do we actually solve this? Well, I can just do 91 is divided by, I want sine of 46. Hit my enter, and it is 126.5. So on and so forth. We're going to round it to 126.5, and I believe that unit was in feet. Oh, nearest tenth of a foot. It even asked us to do that. So that just means that my x right here is going to be equal to 126.5 feet, which, if you kind of look at it in terms of this triangle, roughly makes sense. It had to be bigger than 91. This side, because this would be 44, would be slightly less than 91. So if you kind of do the eyeballing it out, that makes sense. All right, so that is ultimately how you do these sort of problems. As you can see here, it goes through all the steps. Again, you need to use a calculator for this. So if you do not have a graphing calculator, do feel free to use the Google calculator. By the way, the sine, cosine, and tangent functions for your graphing calculator are right above the comma and the parentheses, or right, kind of the second one above the numbers. All right, so if you were to do a problem like this, again, you have an angle, you have the opposite side, and you have the hypotenuse. So I have that sine of 76 is equal to x over 7.3. Now, obviously, this one does make your life easier because I don't have to divide by sine of 76. I just multiply both sides over here. And then if I plug that into my calculator again, 7.3 sine of 76. Let me clear this. 7.3 sine of 76. 7.08, so about 7.1. Which, that makes sense, right? This is a bigger angle than this one, so this will be the bigger side. It's actually a pretty sizable angle, so it'll be relatively close. feet. Okay. All right, so those would be several with sine, but you know that there's more than sine, right? So for example, if you're given this one, right here I have the adjacent, and now I'm looking for the hypotenuse again. What has adjacent and hypotenuse? A and H, cosine, right? So if you set this up, it'd be cosine of 40 is equal to 1.8 over x, and you're going to go through the same process. X is going to be equal to 1.8 over cosine of 40. Now again, you're going to go into your calculator, and you still will do the same thing. 1.8 divided by cosine, cosine 40. Make sure you are still in degree, and it is 2.3. Nope. So it is 2.3, which makes sense, right? .3 feet. All right. If you look down here on the next one, you can go through the steps I showed you. Once again, this will be very similar, right? Cosine, adjacent, hypotenuse, same process. Please try that one just to make sure you know what it is. If you do out the math, you should end up with 7.3. All right, yeah, 7.3. All right. Now, last one that we do need to make sure we understand would be if you are given an adjacent and a hypotenuse, an opposite and an adjacent, we would be dealing with tangent, right? So we are going to go through the process down here. We have the tangent of the angle J, right? That's the angle we are given, is equal to 26 over x. Now, to solve for this, you have to solve once again. Again, tangent of 25 is just a number, so you can still divide by it. And then when you plug it in, once again, here in your calculator, you have the tangent button. There's your tangent button. You'll be able to solve it. So for example, if I gave you something like this is my opposite, this is my adjacent. So tangent of 85 is equal to x over 4.6. So x is equal to 4.6 tangent of 85. If I plug that into a calculator, we have a tangent of 85. I forgot the number that we're multiplying by, 4.6. And 4.6 will be 52.6. All right. So if you do it out, you will end up with 52.6 feet, which makes sense, right? This is a very small angle. It's only 5 degrees. So of course, this is going to be much smaller than that one up there. All right. And you can do one more for good measure to try it out and make sure you're on the right page. Now, what will your answer be if you do this? It will be 19.7. So feel free to check that. Now, I have only so far shown you how to solve for sides, but what about if I needed you to solve for an angle? And that's where things are a little bit trickier. It's the same process, it's just you have to do something called an inverse ratio. You just have to do the inverse trig, which is not as complicated as you potentially could make it out to be. So all you're doing with these is essentially you're setting it up the same way you've been setting it up, except now you have something like sine of theta equals 4 over 7. And I go, what's the angle? And you go, I have no idea. But you know that the trig ratios are there because they are forming a pattern, right? So whatever 4 over 7 is, it's always going to have that angle, whatever 4 over 7 makes. So we can find it. So you're going to do something called inverse trig. So you're going to have the angle is equal to the sine inverse of opposite over hypotenuse. So you'll notice if you have a graphing calculator that right above the sine, cosine, and tangent button in blue letters, there will be sine to what looks to be a -1, cosine to the -1, or tangent to the -1. Other ways you might see this written would be arc sine theta, or sorry, not theta. It would be arc sine of your ratio, arc cosine, arc tan. All right, so those are just another way of writing them. But let's actually go through the process of how you do anything with this. So I need you to find the angle, all right? So let's ask ourselves, what do we know here? I am trying to find the measure of angle x. I have the opposite side from x, and I have the adjacent. So that means I'm going to be dealing with tangent. I don't know what my angle is, it's just x. But I know it is equal to 3.2 over 5, okay? So what you're going to do, basically to undo the tangent, so to speak, is you have to do the inverse of it. And the way that we denote that is going to be inverse tan, okay? So that just means it is the inverse. This does not mean that you put it 1 over tangent of that. No, that's not what that means. This is a specific meaning, just meaning that the inverse of this, okay? It specifically means the inverse. Do not write it as 1 over tangent of 3.2 over 5, okay? Very different. So we now need to solve for this. So to do that, again, I can go back to my calculator. I need to figure out how to get that written here. And if you hit this little in button, INV, gives you the inverse. And I need, I forgot the number for, inverse tangent of 3.2 over 5. Again, please, please, please stay in degrees. Your answer will be in degrees for the purposes of this class. So inverse tangent, and you'll see it comes up as arctan. They mean the same thing. 3.2 divided by 5. Okay, and that is equal to 32.6. So this is your angle. All right, your angle is 32.6 degrees. All right. All that the inverse tangent is doing is it's essentially undoing the tangent. You know the tangent's a ratio, so essentially you're undoing it and you're getting the angle back that gives you that ratio. Okay, so that is all it is doing. And your answer again is a degree measure. Now, you could once again do another one like that, right? This will also be inverse tangent, and you are welcome to solve that. When you are trying to solve this, your answer is going to be 8.3. Okay, so if you were to do that out, it would be 8.3, and I'll leave you to try that. Another one here, now we are given an adjacent and a hypotenuse, so we are dealing with cosine. So you know that cosine of x is equal to 61 over 86. So that means, again, when we need to solve for the angle, you use inverse trig, okay? So the inverse is just essentially undoing the process, and it gives you the angle that results in that ratio. All right. All right, remember 61 over 86, 61 over 86. All right, I'm going to clear that, go back to in, and it's giving you the arc, which means the same thing, 61 divided by 86, and that gives you your answer of 44.8 degrees. That is your angle measure. All right, so that will be your angle measure. And it wants it to the nearest degree, so it's 45. I realized that after. Please make sure you read what it wants you to round it to. All right, so similarly, if you did this one, as you would imagine, this is going to be dealing with inverse cosine. So if you do this out, you would end up with 39 degrees. All right, so I'll leave you to try that out. And naturally, we do have the last one. So we have the opposite and the hypotenuse. So you are dealing with sine. Sine of x is equal to 27 over 82. All right. So that means x is equal to sine inverse, or arc sine, 27 over 82. Okay. So if I plug that in, 27 over 82, 27 over 82. 7 divided by 82. That'll give us an angle of 19 degrees. All right. So again, that is the process you're going to go through. If you're using a calculator, you have to hit the second, so the blue button on the top left, and then whatever trig you are dealing with. Now, if you did this last one right here, you are once again going to be dealing with sine. And it is inverse trig, and your answer will ultimately be 63 degrees. All right. So this is a broad overview of trig. I just want to make sure that you know how to calculate the different pieces of information. We are going to practice more, so do not worry. And then we're going to be applying this. So let me know if you have any questions, and have a great day.